Hi guys, and welcome to today's tutorial. Today I'll be running through coordinate reference systems. So I'll first be discussing what is a coordinate reference system. Then I'll be moving on to what coordinate reference systems are used in Ireland today, how we can identify, so what distinguishes one from the other, okay? And just a few tips and tricks of things we have to look out for when selecting coordinate reference systems. So as we can see here on the screen, we have a coordinate reference system can be defined as a coordinate-based local, regional, or global system used to locate geographical entities. In essence, it provides a common ground for everything to come together. Okay, so how projects can come together within themselves, but also position themselves relative to their environment. Okay, coordinate reference systems used in Ireland today. Currently, we have Irish National Grid, which can also be called Republic of Ireland 1975. Just so you are aware, they both mean the exact same grid. We have Irish Transverse Mercator, and then that has since been superseded by Irish Transverse Mercator, or commonly known as ITM 15. We also have guys using local systems who might want to shift or rotate their grids basically so that they're perpendicular parallel running up their site, so offsets become a little bit easier. In essence, we have two things that really make up a coordinate reference system that distinguish one from the other. A coordinate reference system is made up of a grid, so an X and a Y, as we can see there on the screen, has a theoretical surface which we use for a height reference system. Okay, so traditionally Irish National Grid was, we had the origin, our 000 point, as we can see there on the screen in the larger image to the right hand side. It was located just off the southwest coast of Ireland. When we updated that, we needed to make it easily distinguished from Irish National Grid moving towards Irish Transverse Mercator. So what they did was, as we can see in the bottom left hand image here, they actually shifted the origin roughly around 500,000 meters diagonally left. So what that means then is, so say we're up around the Dublin region there, what we would expect to see from a coordinate, if I ID'd a point, if it was in Irish National Grid, was the kind of everything, whether it's in ITM or Irish National Grid, we'd expect to see 6 figures in front of the decimal point, okay? 9 if it's in millimeters, so 6 if it's in meters. But it's just more, the real indicator is looking at the first digit in the 6-digit combination. So we would expect that our eastings and our northings within Irish National Grid will be up there. You can see in around the 2. Okay, so across 1, 2, 3. So starting with 2 or 3 up around the Dublin region for Irish National Grid. Whereas when we shifted it down to ITM, we would now expect this to be up around kind of the 6, 7 mark starting. So this is the first indicator whether our grid is in reference relative to Irish National Grid or Irish Transverse Mercator. Commonly, if it's using local systems, the digits will actually be a lot lower. So you won't have 6 digits, they might have 3 or 4, because generally they'd start the origin point at 100, 100, 100, or 500, 500, 500, or something like that that makes sense to them, and it's easily computable then to do offsets. Okay, so moving on from this, the coordinate reference system is made up of grids, okay, which specifies where we are located in Ireland relative to the easting and northing. So that positions us a location. But we also then need to know elevations. So as we all know, we reference height relative to mean sea level. What controls the height of the sea, the mean sea level? What we do know it to be is gravitational pull. Okay, so what influences that? Lunar cycles are what have a big influence over this. So what we need to do then is we need to capture gravitational data right throughout the country, so then we can plot essentially where mean sea level would be at that given location. If you imagine a geoid, it's imagine you just have the sea and there was no land and it just kept continuing over the land. That is what the geoid is meant to represent. So what we can see is we as engineers and surveyors, though, are only interested in orthometric height, which is our height above mean sea level, which you can see there displayed as H, capital H. So what we can then define is our orthometric height is equal to our ellipsoidal height minus our geoid height. Okay, so that's essentially what's going on within the inner workings of a GPS, but it's all tying into what a coordinate reference system is. Okay, so moving on then, so why did we move then from ITM to ITM 15? Because the grid is the exact same. However, the difference is the geoid. So that's why if you're using a GPS and you change your coordinate reference system to ITM versus ITM 15, by standing in the same location, we would expect to get the same position within obviously GPS accuracies, within 15, 20 mil in position. However, the elevations could change. An illustration that shows us the difference that we could expect between OSGM, which is Ordnance Survey Geoid Model 02 and 15. So we can see there the yellow kind of lands are the real where there's no real difference, but it gets a lot worse over to the west. That's actually just because of the geological makeup it's a lot more mountainous. That's why the impact will be a lot greater. So it is an important thing to note that if you turn up on site and it's specified that it's ITM, it's always a good question to ask whether, well, is this ITM or is it ITM 15? And a lot of time what you'll find is it's ITM, but they might have actually done a localization and stitched to a known elevation, which could have been a top of a manhole cover or something of the sort. Okay, I hope this video helps you today, but if you have any further queries relating to coordinate reference systems, please feel free to get in touch.